So again, this is the survey data, and as I said in this example, I will show you how to reduce the number of variables and number of surveys and how to conduct more cleaner analysis, okay? And yeah, so this is the background about this the data in this example. So Deepong mailed survey data for 58 respondents, okay? And one set of questions involved the satisfaction with Deepong in 6 primary areas, okay? An additional set of questions were about interest of the company, their size, and the number of employees, etc. And this is examples of Deepong data. So we have some demographic or background questions in the survey. So for example, we have this variables size, the number of employees in thousands, and the revenues, the years, the number of years as a Deepong customer, and the number of products. So number of products that they buy from Deepong, okay? So those are some screening questions or the demographic or background questions. And these are the actual survey questions. So we have this dimension. We have many variables here, many questions here. And the question number 1 through number 4, this is about the quality. So this question asks the quality. And the next type of question, TS1 through TS3, these are the question about technical support. And SM1 and SM2, these are the questions about sales and marketing support. And SD1 through SD7, these are the questions about the supply and delivery. And INN1 through INN3, these are the questions about motivation. So this is the example of the questionnaire. So this is the example. Please rate Deepong on a scale 1 to 10 scale on each of the following questions, okay? So those 4 questions are about the product quality. So the range of the choices in the product line, the consistency of the product, this quality from lot to lot or things like that. And consumers are supposed to rate for each of this product quality, okay? The analysis goals here is the analysis goals we have here are 3, and the first one is introducing factor scores that will be used for the regression models and understand the drivers of revenue, and this is about interpreting the beta coefficient in the regression model, and can the survey be reduced in size for next time, okay? So this is about the simplifying the survey. Okay, so here what we want to do is we first run the regression using the raw variable, raw data. That means the raw data means here is we are using the ratings for the each questions in the survey. So going back here, so we have these survey questions here, and we will get the data. We will get the data for individual questions and from the 58 consumers, right? So here we have the 58 respondents. So the table, the data looks like, even if we don't have it, the data looks like we have the respondents here in this row. So with respondents 1, respondents 2, and all the way to the respondents 58. And in this column we have this the question items, right? So this is the question item. So we may have for this first respondents, we have 8 for the first question or 7 for the second question or things like that, okay? So this is how the data looks like. So going back to this one, so yeah, so using the data, raw data, we first run the regression, okay? We we don't do any factor analysis. We are using the data as it is first and run the models and see the beta coefficient and the model fit. Okay, and then next we're gonna conduct the vector analysis and reduce the number of items to certain number of factors, right? And then we are using the factors for the regression model. So this is another regression model using the factors instead of the items in the questionnaire. Okay, yeah, so this is what we are going to do. So we first run the regression model using the raw data. Okay, so and then we run the second model using the factor variables. Okay, so yeah, let's take a look at the analysis. Okay, so this is the regression result from the model with the raw data. So we have all these question items in the survey. So we don't, this is before conducting the factor analysis. Okay, so let's take a look at the result. Those are the estimates, which are the beta coefficient. And if you look at this, the probability, the p-value, the most of the variables are not significant except for question 3 and question 4, okay? And those two variables are the only variables that are significant in the model. So if you look at the VIF, it looks like there's some multicollinearity issues here. For example, this SM2, the VIF is way over 5, okay? So looks like there's some multicollinearity issue as well. And yeah, so if you look at this summary of a fit, this shows the R square and adjusted R squared, okay, and the number of observation. Yeah, the model fit looks okay. But if you look at this analysis of variance and look at this, the probability, that is the p-value for the overall model. So this is not the p-value for a certain variable. This is the p-value for the overall model. So if it's at a significance level at 0.05, if it's greater than 0.05, then that says this model is not significant, right? So if you look at this p-value, it's over 0.05. So at the significance level at 0.05, the model is not, the model is not significant, okay? So the regression is not significant overall. So this is not good. And any other issue, we have a multicollinearity issue here as well, okay? So yeah, so the next thing we consider here that since we have too many variables here, right? Too many variables, and these are the all question items from the survey. So we may want to consider the factor analysis for these variables, for these questions. Okay, so yeah, from the previous regression, we found some issues, so we decided to run a factor analysis, okay? So what we can do with the factor analysis is we have to decide the number of factors and names for the factors, and we can see if there are any variables we can drop from the survey, and what is the survey basically asking about. So if you want to know how to decide the number of factors, how to name the factors, or how to drop any questions from the survey, if you want to know more about these with more details, please go back to the previous lectures, okay? And we are more focusing on this regression model using factor analysis in this lecture, okay? So yeah, so assume that we ran the model, we ran the factor analysis with the data, and then say that, so what we want to do here is that, so let's skip this slide and we will go back to the slide. So this is the regression model with the factor variable, okay? So we reduce the number of questions to here, the 4 factors, okay? And those are the beta coefficient, then what is going to be the input of these factors for the regression model. Okay, what's gonna be the input data of these factor variables for the regression model. Okay, so that is the question. So going back to this slide, so after you run the factor analysis, so this is the factor loading matrix. Okay, so if you don't know, if you're not sure about this factor loading matrix, please go back to the previous video. Okay, and this is factor loading matrix, and here we can decide many, in fact. Okay, so for example, which variables belong to which factor. So for example, this complaint resolution, order and billing, delivery service, delivery speed, those three variables belong to factor 1 because its values are pretty high. This is all over 0.7, so we decide those three variables belong to factor 1, and those three variables, e-commerce, advertising, and the Salesforce images, belong to factor 2, or etc, etc. Okay, and then we can name them. So if you are not sure how to name them, please go back to the previous lecture. But the general recommendation is to use your intuition for naming those factors. Okay, that's the general rules. And yeah, so just here, another thing that we can do is to get the factor scores, which we will use in the regression model. Okay, so how to get the factor score? It's quite straightforward. So if you just get this the factor loading values, so add all these factor loading values that belong to the factor 1. So here, for example, for the factor 1, we have the three variables that belong to factor 1. So we added those three factor loading values and divided by 3, which is the number of variables. Okay, so basically this is the average score for this three variables under factor 1. Okay, and we can do the same thing for the techniques and warranty score. So you add those two variables under factor 2 that belong to factor 3 that belong to factor 3. Okay, so those two variables are technical support and warranty and claims. So you get the average for those two values. So this is how to get the average, and then that's gonna be the factor score for the factor 3. Okay, yeah, so this is how to get the factor score, and you don't need to compute that manually. Indeed, the software just get us all these values, but still I want you to know how to compute those variables or things like that. And by the way, this is one way how to get the factor scores. There are many, but I think at this level, just to know one way to get the factor score is enough. So yeah, so this is the factor score, and these factor score are going to be the main input for the regression model. Okay, so when you use the regression model, so when you run the regression model with this the factor variable, you are using these factor scores for the regression model. Okay, so now we run the new regression model with the factor variables. Okay, so here this is the result from the regression model. So we have here the 4 factors from the factor analysis, and these factors and factor scores should be decided in that factor analysis stage. Okay, so we get this all the variables here. So we have 4 factors, and those are the coefficient for these variables and the factor variables. Okay, so let's take a look at the result. Yeah, so the R square and adjusted R square looks okay, and this is the number of observation. This remains the same. And if you look at the parameter, yeah, so we can see that the magnitude and the signs of each variables in the model, and these are the beta coefficient for these 4 factors. And if you look at this, the p-value, only the factor 1 is significant enough, okay? Yeah, so that's okay. And how about the VIF? So how about the VIF? If you look at the VIF, now the multicollinearity issue is gone. So we don't have any variables whose VIF is over 5. So it looks like we are good and sound. The multicollinearity issue is gone, okay? Yeah, so if you look at this, the overall model, the probability of the overall model, it is significant now at 0.05, right? So this is less than 0.05. So now the model is overall significant. So yeah, so this is what we can get from the regression model with the factors. So the multicollinearity issue is gone and the model is significant. So we got the better result with these factors. So this is why we are using the factor analysis. So the most important reason is that we resolve that the multicollinearity issues that arise from this just too many questions in the survey, okay? So we reduce the dimension to the factors, and we are using the factors as input for the new regression, okay? And are the issues still present? I don't think so. This looks pretty great. And the preview, maybe there are customer segments with different relationships between revenues and factors, the cluster for the factor scores, and the regression by cluster, and we will deal with that in the segment. So yeah, this is just preview, so we will deal with this with more details. So the interpretation of the result in the original regression, we saw the question 3 and question 4 are significant. In this new regression, we found that the factor 1 is significant, right? And the signs of the coefficient estimate for factor 1, this is negative, right? So this is negative. So if we have this bivalent fit of revenue by factor 1, it shows this the downward trend between those two factors, okay? So yeah, so we can check the signs of the coefficient estimate. Any other surprising result? I don't see that surprising result here. And are we modeling the right outcome variables? Okay, so yeah, so those are the considerations that we have. Those are the considerations for the interpretation of the result. The real data is pretty messy. So the data we saw in the previous lectures, the toothpaste example and the haircut, hair product, those data are very clean. Those are clean data, and the real data is pretty messy. So yeah, we have to consider the several steps for the data analysis. So for example, in this lecture, we deal with this default example, and this data seems real enough. Yeah, this data is real enough. So in the original regression, we saw that the model is not significant, and there are some multicollinearity issues around the X variable, and that's the real data. Indeed, that's the data that we met in real world. So pretty much always we found this multicollinearity issues with our data set. So we have to consider this, the factor analysis and or things like that, to remove this the multicollinearity issues from the model or things like that, okay? And we cannot expect much signal in predicting revenue given a small survey, right? So the revenue may be involved with many more factors besides this besides the result from the survey. So there could be the advertising involved, and there could be the brand strength involved. So there are many factors that decide the revenue of a certain product or company. But in this example, we regress on factor score. So regressing on factor score is better than the regressing on questions directly. That's what we found. Okay, so going back to this picture, we see that the multicollinearity issue is now gone. So we know that and the model is significant. So based on this result, we see that the regressing on the vector scores is better than the regressing on the questions directly. Okay, yeah. So this is for the factor. This is the last example. Okay, so let's now move on to the perceptual map. The perceptual map is a visual presentation of the factor analysis. But this is not only for the factor analysis. This can be also used for the cluster analysis that we learned, and the PCA, which is the principal component analysis, which is another dimension reduction technique, which I didn't introduce in this course. But overall, this perceptual map is for the dimension reduction technique and visualization of the result from the dimension reduction techniques. Okay, so yeah, so this is very useful to understand where our product or brand is positioned in the market, or to understand the overall market structures of certain industries or the product categories. Okay, so yeah, so this is very useful, the visualization result, and I will introduce that from now on. And yeah, so and I will also introduce that how the factor analysis works with this the perceptual map, and how to use this perceptual map for the marketing strategy. So the perceptual maps are created based on the factor scores that we learned in the previous lecture. Okay, so those are the factor scores. So this is the scatter plot of composite score, and composite score is same to the factor score in this context. Okay, so yeah, this is composite score, and we have the two dimensions here. One is extraversion and another is diligence. So this is about the personality. Okay, so we have two types of personality dimension here. One is extraversion and another is diligence. Okay, and this is the composite score or factor score that we get. Okay, and then we know which observation is positioned in which place. Okay, so for example, these observation up here, right up here, those are the extroverted and the diligent, because the factor score for these observations are high both on this extraversion and the diligence. Okay, and how about this observation? These are extroverted and not diligent, because the score of these observations are under the 0. So this is under the 0 or the close to 0, so or less than 0. So this is the diligence score for those observations that are rather low. So this is extroverted and not diligent. How about these observations? These are introverted, not extroverted, and not diligent, because the scores for these observations are low, both on the diligence and the extroversion. Okay, yes. So the overall the perceptual map, in the perceptual map, generally we have only two dimensions like this. Okay, so we have only two dimensions here, extroversion and diligence. If it's more than two, we should use this three-dimensional map, which is rather complicated to interpret, right? So yeah, so usually for the perceptual map, we are using up to two dimensions. So this example is beer market with brands only. So here the observations are brand, okay? And we have here the 2 dimension, and we don't know what the factor names are, right? We don't know them, and but we know that this is, if it goes this way in this right side, then it is higher score, and this way this is higher score on y-axis, okay? And what we also know, what we can see from this perceptual map is we can see that the distance between the points represent perceptual similarity, right? So if those 2 observations, if those 2 brands are closer, that means those 2 brands are perceptually similar, okay? So assuming that the data come from the customer survey, right? So assuming that the data comes from the customer survey, if certain brands are closer, that means those 2 brands are perceptually similar, okay? Then what about this Old Milwaukee Light and the Budweiser? The distance between those 2 are rather big, right? So that means those 2 brands are perceptually different, okay? So yeah, so things like that. And yeah, so the brands located in the same direction help label the axis or name the factors, okay? So again, from the factor analysis, we know that the factor names are not given. We have to decide based on the result, based on the plot, perceptual map, or the factor loading matrix, okay? So we have to decide that. So this is one source with which we can decide the names of the factor. So how to do that? So if you look at this, the brand, and if you find some commonalities among this brand in terms of their characteristics, then we can figure the name of the dimension, okay? So yeah, just for example, to me, the Michelob color lights and Nilla light, those are all the light, the flavor or the texture or that kind of those I'm not so I don't know so much about the beers, but to me, those brands, those 3 brands, or Core or Miller, those brand looks pretty light. So maybe the x-axis, this dimension is the full body of the beer. So yeah, I'm not sure, but anyway, so based on if you know more about the beer, you may name the factors better than I do, okay? So but in essence, what we can do here is that we can name the factors based on the brand location, okay? So brand located in the same direction, maybe this one, the certain group of brands here, and certain brands a certain brand here, up here. Based on that, the brand location, we can name the factors. So the perceptual map is frequently used before we reposition a brand, okay? So the basic idea here is a perceptual map is a visual representation of how target customers view the competing alternatives in a low-dimensional Euclidean space. Okay, so you know how to get this Euclidean distance, the definition of the Euclidean distance. We know that from the cluster analysis. If you don't recall that, please go back to the lecture in the cluster analysis week. Okay, so just this again, this is just the repetition of that perceptual map that we just saw. So this is the low dimensional. That means we usually have 2 dimensions in that perceptual map. Okay, and this is the visual representation, and this is the perceived position. perceived positions by customer. Okay, and basically the perceptual map is about the reading customers' mind. So how they perceive certain brands in this map, that's what we want to figure from the perceptual map. So going back to this beer example, here the data come from the consumers, so consumer survey. So this is the result based on their responses about the brand, about this beer brand. Okay, so that's what this statement says. So this is a visual representation of how target customers view the competing alternatives, okay, in this low dimensional Euclidean space. So the map has the following characteristics. I already talked about this in that beer example. So pairwise distances between alternatives directly indicate how close or far apart the product are in the mind of customers. Okay, so again, going back to this beer example, so the distance between those two brands are the perceived similarities. Okay, so this is the perceptual similarities based on the consumer's mind. Okay, so that's one characteristics, and another characteristic is the axis of the map. This is underlying dimensions that best characterize how customers differentiate among alternatives. Okay, so going back here, we don't know exactly what this x dimension represent and y dimension represent, but we know that we can name those the factors based on the brand locations in this map. And again, the data come from the consumer survey. Okay, yeah, so this so the axis of the map underlies the dimension that best characterize how customers differentiate among alternatives. So going back to this perceptual map of a beer market, we have the beer brands here, and we have the two dimensions here. And I was not so good at naming them because I'm not, I don't know about the beers so much, but yeah, this is how we can name based on the brand position. For example, this the y-axis is y-axis more represent that if the beer is heavy or light. Okay, so the Budweiser, the Beck's, or the Old Milwaukee, those beers are rather heavy, and the Miller Lite and Old Milwaukee Light and Cool Light, those are the light, okay, light beers. And the x-axis represent that the budget. Okay, so this is budget and this is premium. So the Michelob and Heineken, Beck's, those beers are more premium brand, and the Old Milwaukee, the Meister Brau, those brands are more budget brand. So this is the perceptual map of dining market. Again, we have this two dimension. One is unique versus basic, and another dimension is indulgent versus healthy. So these are the brands of the dining market. So we have several brands here. We don't know what they are, but what we can see from this map is the closer the brands or attribute, the more closely guests associate them. Okay, so for example, those two brands are quite close. Okay, and those two brands. So the red dot is the brand. So those two brands are quite close. So that means the customers more associate those two brands. Okay, as opposed to, for example, this brand and all the way to this brand. This is how to create this perceptual map. There are main steps here. So first, you select the attribute or questions for survey. Okay, for brand, for a certain product, for example, the beer. So you first select the attribute or questions for the survey, and code up and administer survey, so conduct the survey, and we are using generally we are using this rating based method for this survey, and then convert questions into factor using factor analysis. Then we get this composite score or factor score from questions, and using this composite score or factor score, we can visualize the result. That is the perceptual map. Now, how to use the perceptual map? We can use the perceptual map for differentiating our product from other products, and we can use the positioning map, the perceptual map, for the positioning of our product. Okay. First, the differentiation. So when we create this perceptual map using the data from the survey, and then we can see that where our brand is in this perceptual map. Okay, we can see that, and we can also see the other brands, so we can see where other brands or where our competitors are positioned in this map. And if you create this perceptual map pretty comprehensively, meaning if you create this perceptual map with pretty much all the brands in certain market, for example, the beer market, so we know which brand is where in this positioning map pretty comprehensively, right? Then from this perceptual map, we can see that some hole in this perceptual space where there's no brand in that space, okay? And maybe this hole is the place where we can differentiate our product from other products. And the natural next step after the differentiation is positioning, right? So the positioning is a set of strategies that firms develop and implement to ensure that these differences occupy a distinct and important position in the minds of customers, right? Again, the perceptual map is about the minds of customers, okay? So say we first find the hole in the perceptual map, then now it's the time for us to position the product, okay? But our product is unique in the perceptual map, so it should be unique, right? And also our product should be different and better, okay? If the product is positioned is different but it's not better or worse, then there's no point for positioning a new product, okay? So the product is unique, the new product should be uniquely positioned, so it should be different, but the value that we offer to the customers are better. So so after the positioning, we are asking, are we happy with where our brand is positioned in the perceptual space? So how to use the perceptual map? We can understand the market structure of product categories as perceived by customers. So going back to the beer market, we can see that the market structure, which brand is placed in which place in that perceptual map. So that's one thing we can understand. So we can understand the market structure of product categories. And yeah, so another important point is that these results are the perception. Okay, this result is the customer perception. Okay, so mostly we use the customer survey data for this, and we use this perceptual map to select the set of competitors to compete against. So if we create this perceptual map with the multiple brands, we can see which brand is our competitors, okay? so we can figure that out. And third, we image the studies to help position the organization. Okay, we can create these perceptual maps for the organizations as well, not just for the brand or product. Then we can see that in which places our organization is positioned in that perceptual map, okay, with the specific dimensions. Okay, so how do we describe ourselves in a manner consistent with the perception? So yeah, so our strategy, our brand strategy or marketing mix should be consistent with the perception. If you want to reposition your product, organizations, or brand, you can use the different strategy for the advertisement or some promotions or some messages or the marketing mix. You can use the different marketing mix if you want to reposition your brand or the product. You can use these perceptual maps for products. So when you evaluate a new product concept in the context of existing brand in the market, you can use the perceptual map and see where the new brand is positioned in this map. Okay, and then you can evaluate the product concept and where is your brand located with respect to the ideal brand. So you can evaluate that using the perceptual map and develop a name for a new product. Okay, so based on the position of the new brand in the perceptual map, you can develop the name for the new product. The summary for this factor analysis can be used in the following ways. So factor analysis help focus decision making on a few key factors. Okay, going back to that the lecture 3 or 4, we talked about that how to decide the number of factors, right? So we only want to keep the key factors from many factors, right? So there are several criteria to decide the number of factors. So if you don't recall that, go back to that the hair example, hair product example, and yeah, there's a relevant content about how to decide the number of factors. So factor analysis help focus decision making on a few key factors, and factor analysis create independent factors. So that means going back to that default example, we use the factors as independent variables in the regression model. Okay, so we can create these independent variables using this factor analysis. Okay, and then we understand the relationships between variables, right, and how close the variables are or how different the variables are, right? So we can see some the multicollinearity issues in the variables, so which variables is more correlated with other variables or things like that, right? So we can understand the relationship between variables, and we can see this relationship from the factor loading matrix as well. Okay, so yeah, so this is another thing from the factor analysis. And the factor analysis so the result from the factor analysis acts like variables in future studies. So this talks about the regression model with the factor variables, right? So the factor variables, which are the result from the factor analysis, act like variables in that regression model. Okay, so this is another way of using the factor analysis. And finally, the factor analysis, using the factor analysis, we can create the perceptual maps, right? And from the perceptual map, we can understand the position in market.